All right, trying this a second time. So this is the video lecture for Thursday. That's the last day of school for this week for you guys. You'll have tomorrow off. I will be doing in-service, so I do not, but that's okay. Today we're going to talk about linear inequalities. It should be a pretty short video because these are actually pretty similar to linear equations, but let's go ahead and get into it really quick. So linear inequalities is chapter 2.3. Linear inequalities can be solved in the exact same ways as linear equations, but when you multiply both sides by a negative, you need to flip the symbol. And let's look at an example of this so I can show you why. So we have negative 3x minus 1 is less than or equal to 2. So for now, we can treat this kind of just like an equal sign. We're going to add 1 to both sides to get negative 3x equals or is less than or equal to positive 3. Sorry, negative 3x is less than or equal to 3. Okay, cool. Next up, we are going to, normally we divide by negative 3, but for the sake of showing you what we're talking about here, I'm just going to divide by 3. So that'll give us negative x is less than or equal to 1. Now, in order to solve this, we have to multiply both sides by negative 1, right? To do this, when using inequalities, we need to flip the symbol. So instead of a less than or equals to sign down here, we get a greater than or equal to sign down here. Now let me show you why. If we had multiplied by negative 1 on both sides and left the symbol facing this way, we would get this. X is less than or equal to negative 1. Now let's pick a number that actually satisfies this. So let's say negative 2. Right? If x is equal to negative 2, negative 2 is less than or equal to negative 1. So that's fine. Now let's plug in x over here. So if we plug in negative 2, we have negative 3 times negative 2 minus 1 needs to be less than or equal to 2. Negative 3 times negative 2 is 6 minus 1 less than or equal to 2. 6 minus 1 equals 5. So 5 is less than or equal to 2. That is obviously not true. Now, if we do it this way, we have x is greater than or equal to negative 1. We can use, let's say, 0. 0 is greater than negative 1, so that should work fine. We plug in 0 here, we get 0 minus 1 is less than or equal to 2. Negative 1 is, in fact, less than or equal to 2. So we just need to flip the sign around anytime we multiply by negative 1. Multiply or divide by a negative number, basically. If you flip the positives and negatives on both sides, you need to flip the sign as well. Okay. You'll get plenty of practice with this, so hopefully it won't confuse you too much. But just in case, you can always check your answer with inequalities, because sometimes it does get complicated as to whether or not you should have flipped the symbol or not. So let's say you had this equation. You solved negative x plus 3 is less than 3, and you got that x is less than 1. You can pick any number that is less than 1. So like, let's try 0. 0 is less than 1. We plug in 0 here. We get, let's try, okay. So in this case, it said, let's try negative 1. So let's do that instead, I guess. We get 1 plus 3, which is equal to 4, and 4 is not less than 3. So in this case, you probably forgot to flip your sign. So this should be x is greater than 1. And if you have x is greater than 1, you will in fact get, it should be greater than 0 though, so I'm not sure why it's 1 anyway, but it doesn't really matter. Dual inequalities. So one of the major differences between equations and inequalities is that inequalities can contain two symbols. So like here, we have 3 plus x is less than 2x is less than 15. When you have an inequality like this, you want to solve both inequalities separately. So you want to solve these two equations instead, right? I just took this half, and then I took, let's do a different pen color. Let's go green. And then we took this half. Right, so that's this one. And we can solve each of these individually. So in this case, we have 3 plus x is less than 2x. So 3 is less than x. Yeah, and we just subtract x from both sides, and ta-da, that one's solved. And then this one, we can just divide both sides by 2, which will give us x is less than 7.5, and then you can recombine these, right? So we have 3 is less than x is less than 7.5, and that'll be our answer to that one. And you can check it by picking any point. Let's say we do x is equal to 4, so we'd get 8 here. We'd get 7 on this side. 3 plus 4 is 7. 7 is less than 8, which is less than 15, so that checks out. Okay. So the other things we want to talk about during this, I don't want to go over how to solve graphically again and solve numerically. You guys hopefully got some practice with that last time. If you have questions about it, I'd be happy to answer them in class, but for the sake of the lecture, we want to keep moving along. So let's talk about set builder notation. You've already seen this before. You probably don't know the name of it yet, though. I didn't until I read the chapter, to be honest with you. So set builder notation uses the variable separated from an inequality by a vertical line, and the whole thing is surrounded by those kind of funny looking squiggly brackets. So that's this. I'm sure you've seen this before. I think it might have even been on your quiz. But this is called set builder notation. And it's basically just saying that all the values of x that are possible are x is greater than 3. It's really just a fancier way of writing x is greater than 3, to be honest. But it does tell you that the points of x are all of this. So another version, all the points of y, 2 is less than y, which is less than or equal to 5. So yeah, this is just whenever you see these weird squiggly parenthesis things and some variable separated by this line, followed by an inequality, closed weird brackets. That looks really bad, but whatever. That is set builder notation. So if the book asks for one of your answers in set builder notation, you're going to want to write it like this. And the variable you use here is just whatever variable is going to be in the middle or in your inequality. So hopefully that's not too complicated. It's basically just writing an inequality instead of interval notation, which is what we're going to talk about now. Now, you guys have already done interval notation. We've already talked about it a bit. We did that in our first quiz. But it was something that people were still kind of struggling with, so I want to try to break it down a little bit more in detail here. So linear equalities, rather than with equations, you usually get one answer, right? X equals 4 or x equals 2 or x equals -7, whatever. You get one answer. With linear inequalities, you get, because linear inequalities include a set of numbers rather than a single answer. It can be helpful to write the possible answers in interval notation. Interval notation writes values much like coordinate pairs. So remember, coordinate pair is x comma y. But instead of an x and a y value, the numbers represent a minimum. So your minimum should be on the left and a maximum should be on the right on a specific interval. There are also different types of brackets, and those brackets we'll go over in just a little bit. But remember, they are normal parentheses and square brackets like that. So to write a number in interval notation, you first need to determine the smallest and largest values on your interval. If there is no smallest or largest value possible, so like if it goes on forever to the left, if you're thinking about a number line or a graph, or if it goes on forever to the right, then you would use negative infinity for the smallest or positive infinity for the largest. If the numbers you list are a part of the graph, you use square brackets. So for instance, if I have x is greater than or equal to 4, right? So first of all, my smallest value possible is 4. If I picked 3, then x is no longer greater than or equal to. So 4 is the smallest possible value, which means I'm going to have 4 on my left side of my interval notation. It can go on forever. There's no limit, right? I can do 10 million and that still satisfies this condition. So it goes on to positive infinity. So that's going to be my maximum on the interval. Now, infinities, because they technically don't actually exist as numbers, they go on forever, they're always going to use a parenthesis. Right? You're never going to use a square bracket for an infinity sign. But this 4, because it is included, right? If I pick x equals 4 for this, it does satisfy this condition because we've got this equal to, right? It can be greater than or equal to 4. So that means that this is going to use a square bracket because that is included in my possible x values. Right? If this was just x is greater than 4, then I can't actually be at 4, so I would use a normal parenthesis. So basically, if you see this equals to, if you see this equal to sign, you're going to use a square bracket, and if you just see a greater than or less than, you're going to use the normal parentheses. So this right here, if the numbers you list are not included on the graph, you use a normal parentheses. Okay, so let's practice writing the following in interval notation. If you want to actually try these on your own, please pause the video. Go ahead and take a minute to do that. If you don't, you can just follow along. So first of all, x is less than 3. I have no minimum value here, right? I can go on to negative infinity. So we know negative infinity is going to be my lowest value. And then my biggest value possible is going to be 3. But 3, negative infinity is not included. Negative infinity and infinity will always have a normal parentheses. 3, since we don't have an equal sign, it can't actually be 3 if I have x equals 3. That doesn't work because 3 is not less than 3. 3 is equal to. So we're going to have a normal parentheses here. Now this one, x is greater than or equal to 7. So the smallest possible value I can have is 7. And it is, in this case, whoops, probably shouldn't have written it like that. In this case, 7 is actually included, right? We've got an equal symbol. X can be 7. That satisfies our condition. So we're going to use a square bracket. And then there's no maximum possible value here. So we have it goes to positive infinity. You don't necessarily need to write out the plus. It's sometimes helpful, but it's not necessary. And again, infinity, we always use normal parentheses. Now this one is a little bit different. This says that 1 is less than x, so x is greater than 1, and x is less than or equal to 12. So the minimum possible value that x can be is 1, so that's going to be on our left side. That's our smallest possible number. 12 is our biggest possible number, so we've got a comma 12. Okay. Now, x must be greater than 1. It can't be equal to 1. So we need to use a normal parentheses on the 1. But x can be equal to 12. It's less than or equal to 12. And since it can be equal, we're going to use a square bracket. Okay. So that's all you have to do for that one. Now the last one, a little bit more complicated. We've got 2 separate ones, but they are combined. So x can be anything between negative 12 and 0, and anything between 3 and 20. So in this case, we're going to need to write 2 separate interval notations. Let's look first at this one. So negative 12 is our smallest possible value, and 0 is our biggest possible value on that interval. Since this is just a less than sign, 12 is not an actual option, so it's normal parentheses. On the 0 side, though, we have this greater than or equal to, so we know that this is going to be a square bracket. Then, since we're adding a second set of data, we want to use this union symbol that looks like a U, like that. And then we'll start our next one. This one is between 3 and 20. 3 is the smallest possible value. 20 is the biggest possible value. This time around, though, our equal sign is on the 3, so the square bracket's going to go here. And then since it is less than 20, there's no equal to sign there. We are going to use a normal parentheses. So this is how you would write the interval notation for that. Okay, you're going to get some extra practice on interval notation on this homework assignment. Those of you that are comfortable with it, that is good. The extra practice shouldn't bother you. These shouldn't take too long. Those of you who need the extra practice, hopefully that will help. But please go ahead and bring questions to me if you have them. This is something that you'll probably be using throughout this term, so it is something you definitely want to get down. But that's actually all we've got for this lesson today. So in class, this is the last day of the week. Hopefully, you guys can get as many questions answered as you need to before the weekend. So if you intend to do any extra practice over the weekend, you can do that. Please don't spend a ton of time this weekend on math. It's not what weekends are for, but do make sure you're caught up and that you're ready to go. And if you have more questions, feel free to email me and stuff. But I will see you guys in class today. Stop recording.